We begin this experiment by taking a 150 milliliter Erlenmeyer flask and putting into it 15 milliliters of 6 molarity hydrochloric acid. We then close the flask and add a thermometer and a pressure gauge. The initial temperature of this flask is 21.5 degrees Celsius and the pressure is 1 atmosphere.
We then proceed to add 0.25 grams of zinc into the mix, and the solution is stopped up. At once we can see a reaction happen where the solution bubbles because hydrogen gas is being released, and the temperature initially rose to 26.5 degrees, which is a temperature change of 5 degrees Celsius. The pressure rises from 1 atmosphere to 1.7 atmospheres. As we can see, we are performing a single replacement reaction. So 1 mole of solid zinc reacts with 2 moles of aqueous hydrochloric acid in order to form 1 mole of aqueous zinc 2 chloride and 1 mole of diatomic hydrogen gas. So it's a single replacement reaction, which means one ion, which is hydrogen in this case, moves out of the compound and switches with the zinc in order to form zinc 2 chloride and hydrogen gas. So we're currently waiting on the reaction to complete, which means waiting for the solution to cool down to about 22 degrees Celsius. Okay, almost there.
Now that the reaction has fallen back within 0.5 degrees Celsius of the initial starting temperature, we can pretty much call this reaction over. As you can see, the temperature initially rose very high, 5 degrees Celsius over the initial temperature, and then continued to drop after that initial reaction. The pressure rose to 1.7 atmospheres, which was 0.7 atmospheres higher than the initial pressure, and then it has slowly been falling back down, whereas now at 0.68 atmospheres higher than the original.
Now, completing the reaction, we are going to draw out the hydrogen gas, so we no longer need this thermometer or this pressure gauge, and we're going to take a gas syringe and we are going to draw out all of the hydrogen gas. As you can see, our reaction made 92.4 milliliters of hydrogen gas. This is Grace Kehoe and Mary Glenn Dillard, and that is our experiment.